Let's look at some simple probabilities dealing with coins, dice, cards, and tables. And I mean real simple for purposes here. First thing, coin. You understand the anatomy of a coin. One side is heads, the other side is tails. You flip it, you're going to get one of those two things. That means that our sample space consists of two outcomes, and those two outcomes are both equally likely. And if that's the situation, if we've got equally likely outcomes in our sample space, then the probability is really easy to calculate. The probability of heads, right? The probability of head, we consider head to be a success in this first one. The probability of that happening is how many successes there are over how many total outcomes there are. So there are two possible outcomes, heads and tails. One of those is head, so the probability of that is 1 out of 2. And the probability of tails also, not to insult your intelligence, but there's one tail out of 2 outcomes, 1/2. If we take the probability of each of the things in the sample space and add them together, we should get 1. 1/2 plus 1/2 is 1, of course. A single flip of a coin does not get much more interesting than that. Or it doesn't get any more complicated than that. That's not interesting at all. Let's take a look at a die. We have a cube. If we roll this die, each side is equally likely to come up, and there are 6 of them. So we have 6 possible outcomes. That's our sample space, 1, 2, 3, 4, 5, and 6. Each of them are equally likely. So the probability of any one of them happening is how many there are in that outcome. I'll get to that in just a second, divided by the number of possible outcomes. So how many ones are there on the die? Just 1 out of a total of 6. So 1 in 6 is the probability of rolling a 1. The probability of rolling a 6, same thing. There's 1 6 on the die out of a total of 6 numbers. What's the probability of rolling a 7? Well, there are no 7s on the die, so that's impossible. So our probability is 0. Divide that by 6, you still get 0. What's the probability that our roll is even? That's pretty simple. 2, 4, and 6 are even, so 3 of them out of the 6, or 1/2. And what's the probability that our roll is greater than 2? Well, 3, 4, 5, and 6 are all greater than 2, so that's 4 out of 6, or 2 out of 3. Okay, so anything greater than a 2 would be a success. The number of successes is 4 divided by the total number of outcomes is 6. Pretty simple stuff. Let's make it slightly more complicated. I've got a simplified deck of cards here. In recent years, people have played cards less than they used to. We still need to use them for a very specific reason that we'll get to later. But I simplify the deck here. For each suit, we've got diamonds, we've got clubs, we've got hearts, and we've got spades. For each of these suits, I've taken just ace through 10. So you can think of the numbers 1 through 10 for each of them. There's 40 cards here, 10 clubs, 10 diamonds, 10 spades, and 10 hearts. Also, I don't think yes, I did a color sample on here. Clubs and spades are black. The suit is in black on the cards. And then diamonds and hearts are red. So if I draw a card at random from this deck, what's the probability it's going to be a heart? Well, there are 10 hearts, right? Each suit has 1 through 10. So it's going to be 10 out of the total number of cards is 40, which reduces to 1/4. That makes sense. If the deck consists of 4 suits, then the probability of any one suit is going to be 1 in 4. What's the probability if I draw a card at random that that card's going to be an ace? Well, there are 4 aces, 1 for each suit, out of 40. So that's going to be 1 in 10. What's the probability that the card I draw will be red? Well, 2 of the suits are red and 2 of them are black. So I've got 20 red cards out of 40, or you can just think 1/2 of the deck is red, so your probability is going to be 1/2. And what's the probability that the card I draw is going to be greater than 7? Well, 8 9 and 10 are all greater than 7. So that's 3 in each suit, and there's 4 suits. So that's going to be 12 out of 40, whatever that reduces to. That's divisible by 4. So that's going to be 3 out of 10, or 0.3. We'll get to expression of the numbers later. Just want to talk about the number of successes divided by the number of possible outcomes here. Right? Fairly straightforward. Let's look at one more. I've got a table here, totally made up data, intentionally so the numbers work out nicely. I've got a population here of boys and girls, some of whom love statistics and some of whom don't love statistics. You can decide which box you belong in. First thing you want to do if you're given this is a little bit incomplete. I want some total numbers here. I got 10 boys who love statistics, 20 who don't. That's a total of 30. So I want my totals out here. 30 who love statistics and 40 who don't. There's a total of 70 girls here, and 70 plus 30 is 100. If I look at my columns, 10 plus 30 is 40. So there's a total of 40 people who love statistics and a total of 60 people who do not. And that also adds up to 100. Okay, so if you're not given those totals, make sure you fill those in either on paper or in your head, whichever. Now, looking at our table, if I pick a person at random from this population, what's the probability they're going to be a boy? Well, the top row is boys, 30 out of a total of 100, and that's going to be 0.3. I'm going to accept fractions, I'm going to accept decimals, and I'm going to accept percents here for all of these. If I pick a person at random from this group, what's the probability they love statistics? That would be these 40, the 10 boys and the 30 girls, so 40 out of 100, or 0.4. What's the probability if I pick somebody at random here, they're going to be a girl? Well, there's a total of 70 girls out of the 100, 0.7. And the probability that they're not going to love statistics would be that they come from this part of the population here, these 60, that's going to be 0.6. Now notice something really quickly. Everybody in this population is either a boy or a girl, so if you take those two probabilities and add them together, you should get 1. And everybody in the population either loves statistics or does not, so if you take those probabilities and add them together, you should get 1 also. All right, that's simple probabilities. Let's move on and make them slightly more complicated.